Hi everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This event is one of such events. And if you want to find out more about the events we have, so there is a link in the description. You can just go there, click on this, and you can see all the events we have. So far, I think there are only two. I'll announce more events soon. So keep an eye on that. Then, of course, if you haven't subscribed to our YouTube channel, now it's the best time to do this. Just go below this video, click on this, and you'll get notified about all our videos, and then join our Slack for amazing data-related discussions. During today's presentation, you can ask any question you want. Go to the live chat, click on the pinned link, and ask a question. Ask your questions, and then at the end, we'll be covering these questions after the presentation. So that's all. Nick, you can start. The floor is yours.
Yeah, let me just share my screen with my presentation. Just a second. So yeah, here we go. So today we're going to talk about notebooks in production and whether it's fun or not. So I will start from some introduction about myself. So my name is Nick, and I'm staff data engineer at Delivery Hero. I'm originally from Ukraine. 5 years ago, I moved to Berlin, Germany. I've been working as software engineer for the last 8 or so years, but the last 5 years I was mainly focused on the data and ML field. And for the last 3.5 years, I've been working for Delivery Hero on delivering different ML solutions to improve our product. About a few words about Delivery Hero. So Delivery Hero is one of the biggest food deliveries in the world, but the brand itself is not really known since we have different brand names all over the world. We are really big on the Asia, Middle East, and South America. For instance, Foodpanda, and for folks who are from Berlin, you can even use it since the summer. Foodpanda app, honestly, right now it's working even better than Volt, which is a surprise. And the mission, basically, of the company was to become the global leader in the food delivery. And for the last 2 years, we've been focusing as well on the quick commerce, on the different groceries, and trying to kind of expand the portfolio. So just a bit of the history. The company was created in 2008, and then we slowly started growing and growing. One of the biggest years in the company history was 2017 when Delivery Hero went public, and last year we joined DEX, and this year we became carbon neutral, which was a big step in the company, I would say, and I think it's really good mission that we managed to accomplish. So Delivery Hero, as I mentioned earlier, basically a tech brand, but we have different brands across the world, and basically we can just call ourselves as the house of brands. You can see a few of them. For example, eFood is a brand from Greece. Then Bilozerov is a big brand from South America. Talabat and Yemex, Sepeti, they're leaders on the Middle East. And I will start from the kind of our engineering story. When I just joined Delivery Hero, it was only myself and engineer manager, and we started working on our first machine learning use case. A few months later, data scientists joined us, and essentially we're just a small team of 3 people. I was taking care of the mostly infrastructure and data engineering part, and data scientist and engineering manager, they were kind of together working on the data science part in order to bring our first model live. The story is important in order to understand why we actually decided to go this way and to use notebooks in production at the first place. A few use cases that we have been working on, it was food preparation time model, basically we try to build a model which would make estimations when the food is going to arrive to our customers. So a bit of the background: Delivery Hero has two types of delivery. This is our own delivery, our own fleet, basically our own logistics, and then delivery by the restaurants, which called marketplace delivery. And when it comes to logistics delivery, basically we have all the data points that we need in order to make the reliable predictions when the food is going to arrive to our customers. But when it comes to the restaurant delivery, we have the couriers from the restaurants, and this whole process involves a lot of people interaction and a lot of human mistakes. So for instance, quite often people in the restaurants, they forgot to press the button, hey, the food is ready, or the food was picked up. And essentially we don't really have so many data points in order to make reliable predictions for our customers when the food is going to arrive. Essentially, this is the problem that we were trying to focus on, because the logistics part was covered by our own logistics data science team, and we were trying to tackle this problem when we don't have that many data points, and trying to make predictions when the food is going to arrive when the food is going to be delivered by the courier for the restaurants. Another big use case that we were working on, it was voucher chart model, together in collaboration with the marketing team, and we were trying to make the model which would make reliable predictions, selections essentially of the voucher for our customers in order to charm customers. And we'll start about JPG Notebooks. As you all know, essentially just HTML page in your web browser where you can just write your code, you can execute the code, and it supports a lot of data science libraries, and it's one of the main tools when it comes to the model development currently. JPG Notebooks, they consist basically from the two parts: is the own its UI and then execution parts, which are actually running the code that you're writing in the notebook. And as you can see here, basically you as a developer, you just develop some code in Jupyter UI, and then you run a button execute, and the code is going to be executed in Jupyter server, and then you will get the results. What we actually can say good about the notebooks: everyone in the data science world familiar with the notebooks, and basically when someone joins the team and the whole team is focused on the development in the notebooks, it reduces the onboarding time, because this is like one of the known tools and everyone knows how to use it. The JPG Notebooks is quite easy to work with, and even if you don't have any experience, you can just pick it up really easily. It's quite explanatory and quite easy to start with. In the JPG Notebooks, you can do quick iteration cycles. Basically, you're writing your code, you're changing your code, you can execute part of the code, you can get the result immediately. And the community is really huge. That's why I have a number of the extensions that you can use, from open source to paid ones, and essentially like the whole ecosystem is really big, which helps you to build a lot of helps you to build the whole platform around JPG Notebooks. But what we can say, what people really usually don't really like about JPG Notebooks, it lacks of live collaboration. So if you're working in the big team, you basically work on the single notebook, and then you need to somehow share it. You need to share it with your peers. Back then, when we were still working in the office, it was more or less like easier. You can just come over to someone and show him your notebook, and you can just work together. Currently, it's becoming like a bit more difficult, since a lot of people working remote, and this becomes even more critical problem. JPG Notebooks is quite difficult to incorporate in a typical development lifecycle, since you cannot simply use it. You can add the tests, you can test it easily, and it was the Jupyter Notebooks, they were never part of the development lifecycle. No one was using it in this way. They don't support parameterization. So if you're, for instance, you have your model developing Jupyter Notebooks, which could be used by, in our case, it was many countries, and essentially the model is the same, but the parameters might be different. It becomes really difficult to work with, since essentially you need to create for each country, you would create a separate instance of the notebook, essentially with the same code base, but with different parameters, and then you ended up with really messy and a lot of numbers of the files and the notebooks, which really difficult to track. There is no version control, which is really could be a painful nowadays, since you cannot track the history. You don't see who changed something and why. And of course, if Jupyter Notebooks, they always can be messy. The funny part, a lot of people, they are really against putting the Jupyter Notebooks in productions, and I just picked up some like quotes from Reddit and from Twitter, from everywhere. Like people say, no, I would never put them in productions. This is the joke, and data scientists need to should never try to deploy notebooks in production, and we always need to convert those notebooks to real Python code, and data scientists needs to always get the help from data engineers. But this is not always the case. We decided to actually not tackle, but challenge this common kind of belief that you cannot use Jupyter Notebooks in production. And why we did so? Because we always quite a small team, and we want to iterate really fast, and we didn't want to put any dependency on the data engineers. Basically, we wanted to give the freedom of data scientists to kind of decrease the time that he needs to develop the model and put it to production. So we wanted to be really, really quick in our model development and give complete autonomy to data scientists. At the beginning of when we just started thinking about this whole idea using Jupyter Notebooks in production, and we decided to think about what we actually want to achieve with this whole approach. And one of the keys that we decided to highlight and put like the key achievements was to allow data scientists, to give data scientists possibility to easy and quickly deliver models to productions without much help from the engineers. Then we wanted Jupyter Notebooks to be support versioning of the notebooks in order to iterate of the versions and always be able to kind of switch to the version, back to the version, see how did we change, and have some backtracking. We wanted to share the results with the stakeholders, essentially with the business people. We wanted to incorporate engineering practices in the whole life cycle. We as well wanted to add some templating functionality, which would help data scientist when he just started with the new notebook to easily kind of use the same template, use the same libraries to kind of have the same common structure, which would be easy to reuse for the rest of the models. And of course, we wanted to make the release cycles really short and quickly iterate on our models. And what we actually built at the end. On this whole picture, you basically see the whole diagram that the whole architecture that we actually created. So we start from the data scientist or data analyst who is working on the UI part, basically on the model development. In our team, we were using Amazon Sagemaker and essentially Jupyter Notebooks inside the Sagemaker for model development. Then we used Review Notebooks tool, which is paid service where you can actually connect the service with your GitHub, and then give possibility to do complete pull request reviews like you would do on the GitHub, but with notebooks. So as you all know, if you would try to open the notebook on the GitHub, it's quite huge. You will just end up with crashing. You won't be able to review every cell, every row. It's just impossible. With the review notebooks service, it's actually possible, and it really helped us, especially data scientists later on when the team became bigger, to kind of add this collaboration feeling inside the team. Then what after review is done and basically the pull request is approved, we would use combination of Travis CI and Docker in order to build training image for our model, and we would just publish this image to our image Docker image store, which we are using Amazon ECR. And then the next step would be for data scientists to go on Airflow, which we're using for all our ETLs and for workflow management, and just start the training job. The training job would use just build image from the notebook. And this is the most interesting part here. In order to actually train the Jupyter notebooks, we decided to use Papermill, which is kind of known library developed by Netflix, which allows you to train Jupyter notebooks as the real models. Basically, it allows for some kind of parameterization and using open source libraries in order to execute your notebook as the Python code. In this way, we managed to create different versions of the notebooks for different countries in our case, and run parallel training for all the countries separately, just changing different parameters for our notebooks. And as soon as training is done, we would just publish our ready model to our model store, which for model store we're using Amazon S3, and then the model could be just picked up by anything. In our case, it was EKS, where we're running our Kubernetes cluster, and we would just run our model. We would track performance by BigQuery and Datadog, and we have some alerting functionality, which is based on the Slack, Great Expectation. This is kind of the whole view of our architecture that we've built. And one of the interesting part as well is that after each model training, we would just publish the result as the report, which could be used later on by our stakeholders. So we would just publish the results, and then we can just share the report, essentially just notebook HTML, to our stakeholders to take a look. And at the same time, the results could be checked by our data scientists or analysts in order to understand how actually the training went, take a look at some issues, and kind of do the back check before we actually go in live. This is the example of the report that we have. Basically, we keep track of the model name, model version, training date, and then the report name. This way, we can basically have the whole history of all our trainings. And if, for example, notice some model drift, we can just take a look and understand, compare the different versions of the model, and compare different versions of the model results at the end. For Papermill, Papermill allows you to specify different parameters in the Jupyter notebook. As you can see here, this is just example. In our case, we created YAML configuration on Airflow site, where data scientists can just specify any parameters. In our case, it was model name, model version, and entity that we are using. And then those parameters are going to be passed to the Papermill. In the right side, you see the simple example of the execution of the notebook. As you can see, there is just parameter of the input notebook, output, and some parameters. And essentially, in the notebook, you just need to specify the cell which contains your parameters, and the paper mill will just replace them on the execution step. So as you can see here, we have model name, model version, and entity, and those going to be just replaced during the execution from our Airflow YAML config. One of the important part was actually scaling our training jobs. So as you can imagine, for different types of the countries, for instance, we might have different data. The data size of data could be different, and we might need different different jobs configurations, such as memory and CPU. We managed to overcome this problem by just allowing data scientists to change the job parameters on the go. So as well within Airflow, in case the job just failed due to the memory issues, data scientists can just go and change YAML configuration for the job, increase the memory, CPUs, and then just run the job immediately. And the job will just pick it up new parameters and scale up with the new memory configuration. And it comes to actually what we learn and what we like about this approach. With using JPG Notebooks in production, we managed to have really quick delivery cycles because data scientists, he was completely responsible for delivering the model from start to the end without much help from the engineers. For the newcomers, it was pretty easy to pick it up the whole flow, since it was centric around Jupyter Notebook, and basically what you would need to know it's how to work with Jupyter Notebooks and how to work with Airflow, which is essentially quite easy. And most of the people who joined our team, they already were familiar with both tools. In our case as well, I would say works really well when you have highly parameterized models. We managed to kind of reuse the same template, the same model to scale up for many countries. In our case, it was 15 different countries, and basically we managed to use the same notebook, the same job by just change the parameters, like our entity name and some different parameters specific for the training job. And the whole approach is really good for the simple models, but in case when you're working with more like I don't know, deep learning or something else, where you just need to have more resources or like more powerful libraries or some extension, it might not really work out for you, and you probably it wouldn't work to just run simple Jupyter Notebooks for the training. And yeah, as this limitation part, and in case you would need to handle big amount of data as well, you probably would end up creating some ETL pipelines in order to prepare the data, and data should be used by Jupyter Notebooks later on. So you shouldn't use Jupyter Notebooks as ETL tool. It should be just the place where you actually build your model, and you would rather source this data from somewhere already ready for your model to reuse. You need to build really high ownership and responsibility in the team in order for people to understand that the quality of the notebook is really important, and this correlates with the quality of your model, essentially, because your notebook is your model. And because sometimes data scientists or analysts, they used to treat notebooks like as some kind of a template, as some kind of like temporary solution where you can just write whatever you want. It could be messy, it doesn't really work. They never pay attention to how does it look, and they never think about the quality of the notebook. But in this case, you actually need to pay a lot of attention on the quality. Sometimes the resource handling for the training job is difficult, especially if your have a lot of trainings and a lot of jobs over the day. If they fail and if your data is changing, the amount of your data is changing. In our case, it was quite difficult. Sometimes it was difficult, so data scientists would need to go and manually adjust their resources for the job. So the next step would be for us probably is just to think about how we can do it automatically. Basically, if the job is failing due to the memory issue, increase the memory automatically, not wait for someone like data scientists to change it, because sometimes it was a hassle. And the key takeaways basically from the whole work that we have done, the whole approach works really good for small inexperienced teams and the small and the simple models. It's really important to have quality monitoring for your model and for your data in order to make sure that actually your model performing well and you don't put anything wrong to production. You need to test your model. We actually have some integration in unit tests for the whole model. Basically, we just use the model, and before we go into production, we will just run some integration tests, which really helped us a lot of times to find issues with our model. We try to stick to the approach to use serverless technologies, which will help us to achieve a lot of goals really easy and don't really focus on the infrastructure, because when it comes to the model development, we actually want to focus on develop the model and trying to help business to grow rather than spend months on creating the infrastructure around it. And of course, you need to do the code review. And what was really helpful for us is to use this service review embed, which help us really a lot to kind of have good review cycles and to find issues and to share knowledge inside the team. For the next steps, we are thinking about creating more sophisticated solution and incorporate different other tools on the market, such as ML Flow. We are looking into Amazon Sagemaker and the Vertex AI currently, and we want to make the whole approach even more easier for data scientists to use and add more features on the top, such as switch to the feature store, some better model training, and other like model results in version which ML flows, for instance, supporting what we are looking for. And basically, yeah, that's it. And probably it's time for the questions.
Yeah, thank you, Nick. Yeah, I have quite a few questions. I want to remind everyone that if you have a question, there is a pinned link in the live chat. You can click on this and ask a question. You mentioned unit tests. And by unit tests, what do you mean? Like, do you actually unit test whatever is happening in the model? Like, do you have some tests that live near the actual notebook? Or like how does it look like?
No, actually, we didn't really test the notebook itself, but we would rather we tested our model application. So our model application just REST API, which picks it up the model, and we're basically focusing on running the integration tests. So we'd use the real model, the new version of the real model before going to production, and we would run integration tests on the real data with the real model in order to make sure that the results that we have the proper model and the new version is performing as expected.
Okay, got it. So basically you test so whatever happens after the model artifact is produced, so there is something that picks it up, so you test that thing, right? So
yeah,
okay, got it. And yeah, and I was thinking, so for me, the main problem with notebooks when I commit them to, let's say, to GitHub or GitLab, is when I have plots in the notebook. Like it's usually plots are embedded in JSON as base 64 images.
Yeah.
And this is like a long string usually, because you have like this big figure. And then every time you change a figure, then basically like the entire string changes, right?
Yeah.
And then it becomes super difficult to look at diffs.
Yeah.
Does review NB help with that? Like when there are changes in the plot, so they show two plots together, or how does it look like?
Wait, let me think. I don't really remember regarding the plot changes. For sure, you don't have this issue that basically you see the difference in the strings. So I think I'm not sure about how Review handles change in the images, but you for sure don't even see them. You would be focusing on the see the difference between your actual code. I don't really remember. I need to probably check it in terms of the plots difference.
Do you even commit these images, or like when you commit a notebook, do you commit only input, or you also commit the output as well to Git?
Yeah, just the whole notebook.
The whole
so
thing.
Basically, yeah, the whole thing.
Yeah, because it's different. So let's say when you use Peppermill, so you kind of parameterize it, right? So every time it kind of produces a different notebook. The result is different. So what do you actually commit to Git? Like, do you commit the template, right? And this template might contain some output as well.
Yeah, it might contain some output as well.
Okay, clear. Yeah, so these images for me, this is like the biggest problem sometimes, like especially when I try to make sense from diff, this just blows my mind.
Yeah.
Okay, so you don't have a rule like that, like clear output before committing or anything like that?
No, not really.
Okay. And then the other thing I wanted to ask you is, so you said one of the takeaways. So one thing you notice is that data scientists or whoever write code in Jupyter Notebooks, they need to pay attention to code quality. So they cannot treat this as a throwaway thing. So they really need to be careful. Do you have some sort of style checkers or code formatters there for notebooks, or you just ask them to keep the notebook clean?
We actually came up with some rules and templating for the notebooks, how we need to structure it, and plus we use some extensions. I'm not sure if I published. No. So we use some extension for the style formatting in the notebooks, and basically, and as well during the review cycle, we're trying to be mindful about how we actually review the notebook and pay attention to the quality itself.
Okay. Yeah, so I see a question from Ismail is that it's not clear if you deploy notebooks directly or you convert them to scripts and then run.
No, we deploy notebooks directly.
Okay. Yeah, and I guess the main advantage here is
but what does mean by deploying the notebooks? Because essentially we train the job we directly using the notebook to train the job, train the model. So we don't deploy the notebook for like a real application, which is going to be sort of like as the REST API. So we use artifacts from the model, which is going to be used in our REST API. But we don't do this typical conversion when you, hey, data engineer, come over, and you need to convert my Jupyter notebook to the Python.
Okay, so you execute them in your batch jobs, right? So the batch jobs that get some data from somewhere, do something with this data and save artifacts. And along with these artifacts, you save the actual HTML of the notebook.
Yeah.
Right. And then later, from what I understood from your presentation, it's easy to just, you open this HTML and then you immediately see all the report,
because
right?
you see all the output.
Yeah. So you see like all this accuracy, precision recall, and you see some charts. You see like, I don't know, maybe snippets of data, pandas data frames, and all these things.
Exactly.
You could just scroll it through and then see if there's anything wrong there, right?
Yeah.
That's cool. Okay, let me share my screen. Maybe so then it's easier for you to see the questions I'm reading.
Sure.
Okay, so quite a few questions. So how do you go about debugging notebooks? Do data scientists run them locally if Airflow jobs fails?
We actually you can see the errors in the AWS Apache job when you run the notebooks. So you basically, the data scientist, he would just go and take a look on the Airflow job itself on the error output, and then he just understand what is actually going on. But of course, he can run the notebook locally as well. So we try to do everything possible in order to have development environment friendly for data scientists. So data scientists is able to run Airflow cluster locally, and as well the whole our application could be run locally.
Okay. How do you validate that the model is working as expected if you test on real data? Is the data set you test against the same on every test run?
We have some, when it comes to integration test, basically just have some presets that we're expecting to give the results. So essentially, we know that if we put some specific data, and let's say we need to deliver order from A to B, and we know that it should take around like 5 minutes, and the new model basically need to give us results around 5 minutes. So basically we have those presets and we're using them in order to test that model working as expected.
Okay, thank you. How do you structure the notebook to accept inputs? Just expose as a function?
No, not really. So Papermill taking care of the using parameters. So you, in the notebook, you basically just need to specify your cell, tag your cell as a parameters, and then Papermill on the execution phase, he would just go to the specific cell which takes as parameters, and he would just insert all the parameters that you supplied on the execution phase.
So basically the entire notebook becomes sort of a function, right?
Yeah.
Okay, and then it's executed as a batch job, and then yeah, cool. And then all these artifacts are saved, and does Papermill save the actual notebook? Does it do the rendering?
So you can specify parameters like save the report, which would just produce the HTML results.
Okay. Do you have any best practices to develop a notebook which will be executed by Papermill?
Basically, it should be as it earlier. You just need to pay attention to the quality, you need to structure it really well, and probably keep your parameters on the top in order to see the whole parameters for the particular notebook and understand how it works.
Okay, thanks. I think we covered that already. What do you mean by deploying the notebook? I think you answered that question already. Right? Do you have anything to add here?
No, not really.
Okay, how do you manage Python environments for Papermill?
What does it mean? I mean, we have basically a Docker image, which we built with all the extensions, and we're using the same libraries which are used by data scientists on the Sagemaker and on the local machine. So we're trying to keep all the requirements in the same place. And what is important to mention here, probably, that we're using the same repo, GitHub repo, for developing the notebook and for serving our application. Of course, we exclude them on the build phase, but at the same time, we can keep the same requirements file and reuse it for different steps, such as model training, model development in Sagemaker, or let's say model when we need to expose a model as a REST API.
And what if somebody wants to try something new? Let's say they want to try MXNet, and so far you only used I don't know, XGBoost and scikit-learn. Is it easy to install this library to your notebooks?
Yeah, I mean, you can just always do it in SageMaker just by hand. So SageMaker essentially just virtual machine with your Jupyter, and you can just go install and try it out, or you can simply add this library requirements file, and then use your branch and GitHub to pull it into SageMaker.
See. So all you need to do, like when you experiment on SageMaker, I guess you can just do this in your Jupyter cell, like people install whatever.
Yeah.
And then when you actually deploy this notebook, then you need to specify this in the requirements, right?
Yeah, correct.
Got it. Does the notebook inform accuracy so that we can explore if something is wrong?
We actually have some checks. We had some checks in the notebook itself, like the simple ones. Basically, as soon as you build more artifacts, you can basically check that the results is accurate, and in case the checks they are not passed, then the notebook would just fail on the execution phase. Those were the simple ones, but they help us to found some issues during the model training.
Okay. And what happens when something like this happens? So let's say your notebook, this check fails, right? Then you open this notebook and see what is wrong, or
yeah.
See.
So those were like simple asserts, in the cell, so you would just see the results.
Mm-hmm. So when this check fails, you get some sort of maybe an alert in Slack, right? And then you
yeah. So you basically we have the alerting complete functionality. You will get the alert in Slack. Hey, your model training has failed, and then data scientists he would just need to go and take a look what actually happened in the output of the training job.
Mm-hmm. And in this case, would it be easy for them to just pull this notebook on their laptop and debug it with these specific parameters?
Yes. So basically, they would usually debug and execute notebook on the SageMaker, so they don't even need to use the laptop. So they can use the same data, connect to the same data, and basically just change parameters, execute notebook to see the results.
Mm-hmm. And SageMaker is already connected to all the buckets with the data.
Yeah.
And,
yeah.
That's cool. Can we say that notebook cells are actually the set of functions that are called from outside, basically like Metaflow have run class and step functions inside?
You can think about in this way, but of course the step functions in Metaflow it's something different. So the notebook cells it's still like just a cell, but when you're talking about step functions, it's more or less like Airflow itself, when you have different tasks and the steps of the execution, because the cells they're quite limited, so you cannot have like big execution there, and you can just parameterize them. But if you parameterize every cell, you will end up with just a lot of parameters, and then your notebook will become messy. So you still should think about the number of parameters that you supply to the notebook, so it can't be unlimited.
And Metaflow have so step functions in Metaflow is like jobs in Airflow, sort of, right?
Yeah.
Let's see. Okay, I just never used Metaflow. I know it exists, but I never.
Yeah, me neither. So I just know that based on the step function, just heavily connected to AWS, basically into everything. So I think it was one of the cases where we never tried.
Okay, have you tried Plumber?
No, I have not.
Do you know what it is?
I heard about. The name is familiar, but I don't remember.
Actually,
but thanks for the
I think
for the
we
tip.
have
I
a
will take a look.
demo in our channel. So I think Plumber. Yeah, we have a demo here from the author. So this is like it's
cool.
quite a cool tool. So it allows you. So the trick they did there is they don't save the JSON, the actual notebook. So they convert the notebook into a script, but then within the script they treat blocks of blocks of code as cells basically, and then they can easily take this script, Python script, and put it
Mhm.
back as a notebook.
Nice.
So they put what they put in Git is the actual Python file. So then looking at diffs is easy, but then you can easily convert a notebook to Python file and then back basically. So when you sort of check out, then you get a notebook, something like this.
Okay,
So it's
I will check it out. Thank you for the tip. It sounds really interesting.
a cool concept. Okay, and do you save the trained model as a pickle file and use it somewhere?
Yeah, exactly. So this is how we do it.
And then this somewhere, I remember in your case,
We use the
EKS
model
cluster,
store.
right?
Yeah. So we use a model store, sort of say. So we save all the trained model as a bigger file, the model store, which is S3 in our case, and then the models they're going to pick it up by our Kubernetes REST API.
Okay, thank you. Is there some lighter Apache Airflow alternative for automation and pipelines that you can recommend?
I mean, there are like a bunch of different stuff like Dexter, or like you can just do simple cron, right? the most
Make
likely one.
files.
Yeah. Make files, a lot of stuff. But I think Apache Flow is quite good, and like there are like a bunch of the examples. The ecosystem is really big, and you can just use Docker image quite easily, get the Airflow, and just run. But of course, there are like a bunch of alternatives right now. Depends on the use case. I wouldn't say that Airflow is such a heavy tool.
One disadvantage, I think, for Airflow is you always need to keep the thing running, right? So you kind of have to have an instance of Airflow running. Then, like, what happens is if it fails? Well, there are these step functions in Lambda, like Lambda step functions. Then you don't have this. You don't have to have an Airflow server.
Yeah, but it's highly, depends on your use case, basically.
Yeah, because then you also don't have this nice UI. You don't have this easy way of executing things. But yeah, you have to keep a server for that. Okay, is there an option for notebook version control? I think you covered that, right?
Yeah, we're using GitHub and for the version control, basically. So since we keep all the notebooks in GitHub, we can just backtrack all the history and all the changes.
And this review notebook is something you use for looking at diffs, right?
Yeah, the UND. Yeah.
Okay. How do you simply recognize large amount of data in notebooks? How do you propose to start if you have different types of data in data lake? So I'm not sure I fully understand the question. Do you, Nick, understand it?
No, not really. I don't. So maybe like in our case, for instance, we used to have data from different sources. So we have our primary data lake based on the BigQuery, but we as well have some data on S3. So we would, in our case, we just set it up connections to both BigQuery and S3, and then data scientist takes care of the load in the data and just merging the data. Of course, if we're working for some models, we had to work with quite a big amount of data, and we just fixed the problem by adding more resources to our training job. Sometimes, of course, it was quite a lot, but it was an easy way how to basically train the job and don't really focus on building huge infrastructure. But I would say the better solution would be to have some ETLs outside the notebook, which would just prepare your data by using Spark or something else in order to make it more efficient and more time efficient and the cost efficient.
Yeah. So I'm wondering, so if let's say somebody wants to start using notebooks in production, what is the simplest way for them to try and see if it's something for them or not before investing? Because I think you put quite a lot of effort in making this architecture, this process for you. Like it took some time probably to polish it, sort of.
Yeah.
But let's say somebody wants to just test it and see if it's something for them or not. What's the best way? within that?
I think it would be just to build the Docker image with Papermill and with your notebook, and just try to run it somewhere on the infrastructure. Like in our case, we're using AWS, but it's quite easy. So if you're on AWS, you can just do it like in maybe, I don't know, 1 hour or so. Basically, just install Papermill inside, use your notebook, and try to just build the Docker image, push it to AWS, but try to run, and then take a look how it feels, basically for you.
Mm-hmm. And do you think having tools like Review Notebook is a must? Can you live without them?
I think so. Based on the feedback from our data scientists, from the whole team that you're using, so the tool is used inside the company by a lot of people, and we actually had the case this year. We had the subscription for 1 year, and then they really increased the price quite a lot. I think like 5 times or so, maybe even 10 times. And when it came to renewing subscription, of course, the price was totally different. And I asked all the data scientists to basically give the feedback, how useful is the tool. And most of them, they actually said that it really helps them on the daily day-to-day job. And the price, of course, is kind of big, but if it improves work of a lot of people, probably it's worth it. So I would say it's really helpful, especially in the big teams, to use it.
Do you know if there are any free alternatives?
I need to check because they changed the price recently and the all packages, but it probably not really work out for the big team, for the big company. So you need to go enterprise like the biggest one, because they changed the number of the people or the number of repositories that actually available on the GitHub to use it. But of course, you can just actually build the tool itself, because it just uses open source libraries. So you can just take those libraries and just build your version of Review in there. But we decided to just go with the paid version because
sense.
we didn't have time to build the same.
Okay, so you're saying this is just a wrapper around open source tools. So in principle, you can use some of these tools separately.
Yeah, kind of.
In your flow. Okay. Do you know what these tools are?
I don't remember the names. I can just send it basically standard packages, so I remember.
Okay, thanks. It seems we don't have any more questions, and I also run out of questions. Maybe actually I remember the last one. Yeah, we still have some time. So you mentioned that you use Datadog, right? Do you use Datadog for monitoring your web services, these REST APIs, the serve models, or also for something else?
We are using for monitoring the REST API and as well for monitoring the performance of our models. So we log all the request response to our model, and in this way we can actually monitor what kind of predictions we are making with our REST API, essentially with our model. And we even try to use anomaly detection on Datadog and other different detection methods in order to alarm us when something is going wrong. And basically with anomaly detection on Datadog works quite good.
So you have some sort of model monitoring there as well, so you can see if something happens. Do you monitor output mostly, or you also monitor input as well?
Just output, because we don't need to monitor input since it's just coming from our consumers, and we are mostly focusing on the output. But of course, we output to the Datadog both response and request in order to understand what actually is going on.
Okay. Cool. So you just used basically Datadog for building your own model monitoring solution, right? And there is this, I remember using Datadog, it was a couple of years ago, but they have this anomaly detection out of the box. So you can just say, hey, there is this time series, detect anomalies, and if something happens, just send me an alert, right? And then you get an email or a Slack message, right? If there is a rule. Like there is an anomaly in your series, right?
Yeah, exactly. But we as well using great expectations to run the data checks and to monitor the model performance on our data lake. So basically, except pushing the data, Datadog, we push all the request response to BigQuery as well. And then we run great expectations in order to kind of see more kind of get even more monitoring and insights from the data that we have from our model.
Yeah, that's interesting. Thanks a lot. So yeah, this was the question I had. So we covered that. I don't think I have any questions left. Thanks a lot, Nick. Thanks for joining us today. Thanks for sharing your experience with us. This is quite a controversial topic, I think.
Yeah.
So I'm happy to see that it's working for you, and hopefully somebody got inspired and will try to implement something like that in their organizations as well.
Yeah, thank you for inviting me. It was a pleasure. If someone has any questions, feel free to pick me in LinkedIn, email, or whatever. Yeah, and the Slack on the data club. Yeah.
Okay, so I'll put your LinkedIn to the
Yeah, of course.
description.
Yeah, thank you.
Okay, thanks, Nick.
Yeah.
And thanks everyone for asking questions. Thanks for joining us today as well. So have a great rest of your day, everyone.
Yeah.
Goodbye.
Bye.